Good morning, students. I welcome you all to Brihan Mumbai Municipal Corporation Education Department, Online Education for English Medium. Today, we are conducting online education for class 10th, subject Science and Technology, part 1. And the topic which I'm going to take today is gravitation. And the subtopic today which we'll discuss is gravitation and circular motion. This is the first session for my lecture. My name is Mrs. Bushra Ahmed, and our channel nodal officer name is Mrs. Almas Hanouri. So let's begin with the lecture. So today, students, we are going to see chapter number 1, gravitation. Once again, I want to introduce myself. My name is Ms. Bushra Ahmed. I'm from Kajupada MPS Secondary School, Kulla. Now, students, in this chapter, gravitation, by hearing the word gravitation, what is the first thing which comes in our mind? That, yeah, we are walking on a earth and some force is acting on us, which is attracting us, which is holding us on the ground. So we think, yeah, that is a gravitation force. But what is exactly gravitation? What is gravitation force? Which scientist has studied on this? What is the story behind it? What are the basic concepts related to it? There are many more questions, and this is very interesting topic. So we are going to see each and every point related to this. But before going to these, students, first I want to talk about a scientist who has studied on this. First we will see who was that scientist who had studied on this gravitation. Now see, students, this photo is very familiar to everyone, right? Who is he? He is Sir Isaac Newton. Now, who was Sir Isaac Newton? We will see this. He was a great scientist. Sir Isaac Newton, he was born in 1642 and he died in 1727. Was one of the greatest scientists of recent time. He was born in England. Where he was born, student? He was born in England. He gave his laws of motions, equations of motions, and theory of gravity in his book Principia. He had studied in various fields, students, and he has given us much more laws and equations of motions. In addition to this, Newton did groundbreaking work in several areas, including light, heat, sound, and mathematics. Not only on this, student, he has worked on his several areas, such as he has worked on light, heat, sound, and in mathematics also. He invented a new branch of mathematics. What was that branch? This is called calculus, and has wide range of ranging application in physics and mathematics. He has done much more work in physics and mathematics. He was the first scientist to construct a reflecting telescope. Who was the first scientist to construct a reflecting telescope, students? He was Sir Isaac Newton. So this was a small history about Sir Isaac Newton. Now we come to our point, gravitation. How Sir has studied, how Sir has invented gravitation force. We will see this concept. But before this, students, there was a short story from which this idea came into the mind of Sir Isaac Newton. Yeah, that there is some force, there is some attraction, there is some force which is there on Earth. Now let's see how the concept of gravitational force come. Can you see this photograph, students? See there, Sir Isaac Newton is sitting under what? He's sitting under an apple tree. And as he was sitting in an apple tree, an apple falls vertically downward. So can you see the face of Sir? He's thinking something, right? So what might be he thinking? So we will see step by step what Sir was thinking and how Sir came to the conclusion. Okay? Everyone, I want full interest on the lecture, okay? Just students, whatever I am teaching, please concentrate on each and every point, because physics is a very interesting subject. If you will understand small thing here, if your small concept will be clear, then only you can get each and every aspect of the physics. You can understand everything, and science is a very interesting subject, I must say. It is whole related to our daily life. Now see, we will see what sir was thinking. We will see step by step. Now see student, gravitation. The phenomena of gravitation was discovered by Sir Isaac Newton. He discovered the force by seeing an apple fall from a tree on the ground. How he discovered this force? He saw an apple was fall from a tree on a ground. Then he started thinking. What he started thinking? Let's see. He wondered why all apples falls vertically downward and not at an angle to the vertical. He started thinking that why this is happening. He wondered why this apple falls vertically downward and not on any angle, 45 angle, 50 angle to the vertical. Then why do they not fly off in an horizontal direction? Yes, why does it fall down? Why does not it fly off? Again, after much thoughts, he came to the conclusion that the earth must be attracting the apple toward itself. And this attractive force must be directed towards the center of the earth. So after so much thought, what he came to the conclusion? Yes, there is some attractiveness, there is some attracting force, so that attracting force is attracting that apples towards itself, and that attracting force is from earth. Yes, and it must be directed towards the center of the earth. Then only, if it is not directed towards the center of the earth, it will not fall vertical in a vertical direction, right? So he came to the conclusion that yes, there is some attractive force present in a field. The direction from the apple on the tree to the center of the earth is vertical direction at the position of apple, and thus apple falls vertical downward. So he thought that yes, the direction of that attractive force must be in a vertically downward direction. Hence, this apple has fallen straight vertically downward towards the center of the earth. After doing so much thoughts, after doing so much studies, he found that yeah, there is a force which is attracting this apple towards the center of the earth in a vertically downward direction. Can you see this photograph here, students? See, this apple has fallen down vertically downwards towards the center of the earth. Okay, students? So this was a small story how gravitation force was known to us. Okay, this was the story behind this. That's how Sir Isaac Newton came to know that yes, there is some attractive force which he termed as a gravitation force is discovered. Yes, now students, Sir has discovered much more laws also. We have seen some laws in standard 9th, right? So we are going to get a small revision of that 3 laws: Newton's first law, second law, and third law. So let's first go towards Newton's first law. What was the first law, students? An object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. Now you will say, ma'am, we have not understood anything. Will you please elaborate this? Okay, I will make you understand each and every point of this. Okay, student? Now what does this statement means? Newton's first law. Basically, an object will keep doing what it was doing unless acted on by an unbalanced force. It means, students, what? If an object was sitting still, it will remain stationary. And if it was moving at a constant velocity, it will keep moving. Why, students? See, what was Newton's first law? That an object at rest tends to stay at rest. Means what? If an object is sitting, he will be sitting only. And if it is in motion with a uniform velocity, with a constant velocity, it will keep moving with a constant velocity unless it is acted upon by an unbalanced force. If force will act on that object, then only there will be change in its motion. There will be change in the motion of that object. If unbalanced force will not be applied, it will be in the state of rest. It will be in the state of rest, or it will be in a constant velocity, keep moving with a constant velocity unless an unbalanced force is acted on it. Okay. Now, students, this is what Newton's first law want to tell us. Now, see, first law is also called the law of inertia. Law of inertia. Now, inertia, you might be hearing, yeah, this inertia is a big term, but it is very simple. What is inertia, student? The tendency of an object to resist changes in its state of motion. Now, what does this statement want to tell us? Inertia means for student, the tendency of the object to be in the rest, if it is in the rest, or to be in the motion when it is in the motion. That tendency of an object is known as inertia. Okay, students, again, I'm repeating. What is inertia? The tendency of an object, if it is rest, so it will be in the rest. We'll take one example. Okay, if I have a small blue pen, and this blue pen, I have kept it on a table. So this pen is at which position right now? It is in the position of rest, right? So the tendency of this blue pen to be in the rest when it is in the rest position, that tendency is known as what, student? Inertia. And if one ball is rolling down with a constant velocity, okay, constant velocity, there is no change in its velocity. So the tendency of that ball to be in a constant velocity when it is rolling, that tendency is known as what, student? Inertia. I hope now my all student has understood what is inertia. Okay. Now first law states that all objects have inertia. What first law explains us, Bacha? That all objects have inertia. The more mass an object has, the more inertia it has. What? How? The more mass, this is very important point. The more mass an object has, the more inertia it has, and the harder it is to change its motion. Now I will explain you with one example. Now see, student, if I am having a small box of 1 kg, okay, if it is a 1 kg, I can easily pick up that box. I can throw that box. But if there is a box of 15 kg or 20 kg, so it will be very hard for me to change its motion, right? To pick it up, to move it. It will be very hard for me. So as the mass will be more, so inertia will be more, right? So this only what this statement wants to tell us. The more mass an object has, the more inertia it has. Means as it gets harder, so it will be harder to change its motion. Now we'll see one example. Can you see, student, there is one train. This train is known as locomotive engine, sorry. A powerful locomotive engine begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia, and it takes a very large force to change their motion. Now, what does he want to say us in a simple language? I will tell you. Okay. Now, say, can you see a engine, a railway engine? If there is one railway engine, so he has to carry the numbers of boxcar. Boxcar, I want to say the dibbe, jo dibbe lage hote, right? So he that are very massive. The mass is very much more. So he will require very much force to want to make them in action, to move them, to change their motion. And when the engine starts, he requires a more force to change the motion. And when the train started, right, it goes in its rail. So when he want to stop the train, we have to stop the train. So to stop the train also, we will require a large amount of force to stop them, right? So this is only what our inertia want to tell us, that if we have to change the motion of an object which are very heavy, we will require a more force. And if you want to stop them also, which is already in the motion, we will require a large amount of force to stop them. When we come to the concept of an object having heavy masses. Okay, so this was a one example. Now, students, we are going to see Newton's second law. I hope my students are enjoying my lectures. Now we are going to see Newton's second law. What does second law want to tell us? Second law is what? Force equal to mass times acceleration. That is F equals to ma, right? M stand for mass, A stand for acceleration, and F stand for force. Now, what is all this? We will see each one by one. Acceleration. What is acceleration? A measurement of how quickly an object is changing speed. That is known as acceleration, student. What is acceleration? How quickly the object is changing its speed. Kitni speed mein apni, in how much quick that object is changing its speed. That is acceleration. Or we can define acceleration as total quantity of the motion of the object. The total quantity of the motion of an object is also termed as acceleration. And in simple language, if you want to understand, that it is a measurement of how quickly an object is changing speed. How quickly an object is changing speed, that is nothing but, student, acceleration. Now, students, what does this F equals to ma means? We will see that force is directly proportional to mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now see, with the example here, I have explained you that consider there is one ball. He is having some mass and is moving with an acceleration. It means that that ball is having certain force which is applied on it, if it is having a mass and if it is moving. Now imagine we take the ball twice as big, double the mass, but keep the acceleration constant. Now see what we have done. We have double the mass of the what? Double the mass of the ball. Now you tell me, student, if the mass of the ball is increased, so what will increase? We have to increase the force, right? See, all the concepts are interrelated to each other. It is linked to each other. I have now only explained you inertia, right? That to push an object having a mass, we required a force. Now here, see, we are doubling the mass. So what will be doubled? Force will be doubled, right? Because we are doubling the mass. Now, see, we take a ball twice as big, double the mass, but keep the acceleration constant. Then F equals to ma says that this new ball has twice the force of the old ball, right? Now, we will see the next scenario. Now imagine the original ball, M, okay? Moving at twice the original acceleration. Now acceleration is doubled. At that time also, student, force will be doubled. F equals to ma says that the ball will again have twice the force of the ball at the original acceleration, right? So see, this is very simple and very interesting. Now we can imagine each and every things which is around us when we are playing, when we are doing some work. So we can see, yes, these laws are connected to our daily works which we are doing. This is all work on this principle only, on this laws only, right? Now see, student, in other words, see, force, if you will apply, if there is a toy which you are playing, right? This is a truck, a garbage truck. Now if I will apply small force, so acceleration will be small. If I apply large force, so acceleration will be more. So if you push twice as hard, the accelerates twice as much. Means if you will push harder, अगर आप लोग जोर से जब फेंकते हो, so it will go very fast, ना, right? So a large force will give large acceleration and small force will give small acceleration. Now see, there is again one twist. Acceleration is inversely related to mass of the object. How? See, I'll explain you. See, this is an example. There is one car having large mass and one car having a small mass. And the force which we are applying is same for both the things. So students, which car will move fast? Acceleration will be large in which mass? Which car having a small mass, right? See, in the first case, as it is a large mass and applying the force, and that time acceleration will be small as compared to a car having a small mass, and if applying the same amount of force on it, so we'll get a large acceleration. It shows that acceleration is inversely proportional to mass. If mass will be more, acceleration will be less. If mass will be less, acceleration will be more. I hope you have understood this now. Now, this is a summary. The acceleration of an object is directly proportional to the net force and inversely proportional to its mass. That is F equals to ma. F stands for force, m stands for mass, and a stands for acceleration. Now we are going to see Newton's third law of motion. This is very interesting, students. Every action, there is an equal and opposite reaction, right? Now, what does this want to tell us? Every action has equal and opposite reaction. We'll see. For every force acting on an object, there is an equal force acting in opposite direction. Right now, gravity is pulling you down in your seat, but Newton's third law says your seat is pushing up against you with equal force. This is why you are not moving. This is a balanced force acting on you. Gravity is pulling you down and your seat is pushing you up. Now see, student, can you see this chair? So when we are sitting on this chair, students, so we are at the rest position, okay? We are sitting very stable. But there is one balanced force is acting on a seat, then only we can able to sit on a chair. What is that? That gravity is pulling you down and your seat is pushing you up. Hence only there acts a balanced force, and then only we are able to sit on a chair. This was said by Newton's third law, that every action has equal and opposite reaction. Example, we have seen, student, a ball. When we hit a ball on a wall, the amount of force which we are applying on it, with the same amount of force, it is bouncing back to us, right? Now see, Newton's third law described the relationship between two forces in an interaction. One force is called the acting force and the other force is called reaction force. There is two forces, student, action force and reaction force. Neither force exists without the other. Both the force are required. One is depend on other. They are equal in strength and opposite in direction. We all know that they occurs at the same time simultaneously. Now see, with the example you will get to understand. Now see, when action A exerts force on B, the reaction is simply B exerts force on A. Now see, student, when we are driving a car, what is action force here? Tire pushes the road. What is reaction here, student? Road pushes the tire. Then only we are able to move a car on a road. What are the action? Tire pushes the road. And what is reaction? Road pushes the tire. Then only we are able to move. See the second launching rockets. Can you see that? Rocket pushes the gas. And what is reaction? Gas pushes the rocket. When rocket push the gas, that is action. And when gas push the rocket, that is reaction. Then only a rocket is launched. Now see, from a huge building when we are throwing a ball. So what is action here, student? Earth pulls ball in a downward direction. That is action. And what is reaction? Ball pulls the earth. That is reaction. Then only the ball can fall down. This is the action and reaction take place. I hope with this example you have very good understand Newton's first, second and third law. This was a basic concept related to gravitation. Hence I was supposed to take it so that when you are going to the major part, major topics, you can understood it very well. Now see student, now we are going to force and motion. What is force and what is motion? What is force, student? Push or pull required to change an object, that object's motion, that is force. If we are pushing something or we are pulling something to change the motion of that object, that is termed as, students, force. We have seen that force is necessary to change the speed as well as the direction of motion of an object. Now see student, if I'm applying a force on some object, what does it will change? Either it will change the speed of that object or it will change what, student? It will change the direction of the motion of that object. So force is very much required to make an object in a motion. Now see student, there are 4 forces known in universe. There are in universe, how many forces are there, students? 4 forces which are known in the universe. First is electromagnetic, which is caused from electric and magnetic interaction. Second is strong nuclear forces, which is responsible for holding nucleus together in the atom. Strongest force act over the shortest distance. This is a very strongest force, student, because strongest force always acts on a shorter distance, where distance is very short and force are present, that are the strongest force. And what would be the very shortest distance, which is nuclear, which is there in an atom, right? So holding a nuclear into an atom, having a strong nuclear forces. Then gravitation force, weakest force, acts over the largest distance. Why the weak gravitations are said as weakest force? Because they are acting upon a larger distance. And there are weak nuclear force, which is responsible for radioactivity in atoms. So these are the 4 forces, students, which is known to the universe. This should also be known to you. If you want some points, you can note it down in your notebooks also, okay? So it will be helpful for you to get when the lecture will be over. For revision purpose, it will be helpful for you. Now see students, there are types of force. There are contact forces and field forces. You know, if we are in physical contact with some, when we are applying a force and we are in physical contact with that, that are known as contact force. And if the force is present in a field, such as a nucleus is there in an atom, electrons are revolving around it. So there is some forces which is not in physical contact, but which is in a field. So hence they are termed as field forces. Now what are the types of this contact and physical forces? See student, in contact forces, we can say friction and tension. Friction is an opposing force. If an object is in motion and the force which is opposing its motion, that is friction. Tension. So these all are the contact forces. What are the example of field forces? Gravitation forces, electric forces, magnetic forces. These all are the field forces. Now students, we are going to see a very important, very interesting topic, that is circular motion and centripetal force. What do you mean by circular motion and what is centripetal force? Now say student, what is circular motion? With the name only we can imply, yeah, there will be some motion, in a circle is there, some circle is there, right? And motion is taking place. Then only it is named as circular motion, right? So now we will see what is this basically means. What is the concept related to this? Now see, circular motion is an object circular motion is a movement of an object along the circumference of a circle or rotation along a circular path. It can be uniform with constant angular rate of rotation and constant speed, or non-uniform with a changing rate of rotation. Now you will say, ma'am, you have read so big statement and we have not understood anything. I will make you understood each and every point of this statement, students. Now see, what is circular motion, student? When circular motion which is taking along what? Along the circumference of a circle, or it is rotating along a circular path. Circular path. See, if I have taken a thread, a string, and I have tied a stone at the end of it, and I am rotating it. So it will rotate in a circular direction, right? It will rotate in a circular path. That is circular motion. Now come to the next part of this statement. It can be uniform with constant angular rate of rotation and constant speed. If I am rotating it with a constant speed, with a constant rotation constant speed is there, then only, student, it is termed as uniform circular motion. And if it is non-uniform with changing rate of motion, if I will change the rate of motion by the time to time, it means that there is no uniformity in it. And as there is non-uniformity in it, we can say that it is non-uniform circular motion. Okay, students? Now, we are going to next part, that is centripetal force. What is centripetal force? A force acts on any object moving along a circle and it is directed towards the center of the circle is called centripetal force. Now see the force, now see student, I am holding a thread and I am rolling it out. So there is a force which is acting towards the center of the circle, that is centripetal force, which is moving that object in a circular path, helping that object to move in a circular path, and it is directed towards the center of the earth. So towards the center of the circle, that is called a centripetal force. See, centripetal force simply means which is the force which is directed towards the center of the circle. Centripetal, see here, centripetal means center seeking. That is, the object tries to go towards the center of the object, center of the circle, because of this force. See, again I am repeating, centripetal means center seeking. Center seeking means it is directed towards the center. That is, the object tries to go towards the center of a circle because of this force, that is centripetal force. Now, for your better idea, we will see this. See, tie a stone to one end of a string. Take the other end in your hand and rotate the string so that the stone moves along a circle as shown in the figure below. Now see, like this, you have to rotate this stone and with the help of this string in a circular path, means it is having a circular motion. Now see, student, a stone tied to a string moving along a circular path and its velocity is in tangential direction. Now see, our student, the stone which is rotating in a circular motion, what will be the direction of this of the velocity of that stone, students? It will always be in a tangential direction. It will be in a tangential direction. How? See, this is how the uniform circular motion is taking place. Can I play the video again? See, sorry. See, this is a circular motion. Okay, students? Now we are going to see we are going to concentrate on the direction of its velocity. As long as we are holding the thread, we are pulling the stone towards us. As we are holding this string, we are pulling that stone towards us, and it's towards the center of the circle, and are applying force towards it. That is centripetal force. Okay. The force stop acting if we release the thread. Now see, if I am rotating it, and if I will, it is moving in a circular motion, and if I will release it, In this case, what will happen, student? The stone will fly away along a straight line which is tangent to the circle. At the position of the stone, when string is released, it will get fly off. How it will get fly off? In a straight line which is always tangent to the circle. And why it will go to that tangent to the circle? Because at that position the stone was having the direction of that velocity was that, because it was tangent to the circle due to the position of the stone which is released in from that string, because that is the direction of its velocity. And at that time instant, that was the direction of the velocity. Hence, it gets fly off to the tangent of that circle. Now, for better understanding, we will see this. See, if I'm rotating it and the thread is breakdown, the string is breakdown, so it will go fly off, making a tangent to the circle. It means the velocity of the object which is in a circular motion is always what? Is always tangent to the circle. The direction of the velocity is always tangent to the circle. I hope my students have understood this. See, this is a video to make you understand. Now I have cut it. See, cut. So this is how the stone will fly off. See, again, I'm playing it for your understanding. Understood, students? As we cut it off, see. Now cutting. After cutting, it will go straight to the tangent, because at that position, student, the direction of the velocity was that at that time instant. Understood? I hope you have understood this. Now we are going to see some other concepts also, students. Now see, what are the other concepts? Do you know the moon, which is a natural satellite of the earth, which goes around it in a definite orbit? We all know, right? Moon is the natural satellite. So there is some question which is coming in my mind, students. I want to make you also thought this question, okay? What are the question which is coming in my mind? Let's see. The direction of the motion, the direction of the moon, as well as its speed, constantly changes during this motion, right? When the moon is in motion, student, we are saying that the speed is constantly changing during its motion. When the moon is moving, is rotating, is revolving around the earth. So we see that there is always change in the speed. Do you think some force is acting on a moon? Do you think that some force is acting on a moon? What must be the direction of this force? What would be the direction of this force? How would its motion have been if no such force acted on it? If no force is acting on the moon, then at that time, what would be the motion of the moon? Do the other planets in the solar system revolve around the sun in a similar fashion? How the moon is revolving and rotating around the earth, there are some forces on other planet also, due to which in our solar system all the planets are revolving around the sun. This is similar force acting on them also. So this all was, students, question was coming in my mind, and I have came to some conclusion. What are the conclusion I have made, students? From the above activity and examples, whatever we have discussed, the question, it is clear that for the moon to go round the earth, there must be a force which is exerted on the moon, and this force must be exerted by the earth, which attracts the moon towards itself. Yeah, there must be some force, that is gravitation force, which is acting upon a moon, and due to which only the moon is moving, the moon is revolving around us. Okay, so that force is what? The attractive force which is coming from the earth, that is a gravitational force. What about the other planets, students? Similarly, the sun must be acting the force on the planet, including the earth, towards itself. Same as earth is attracting moon, to revolve around itself, same other planets, including the Earth, is also attracted towards the sun, and it is attracted towards the sun by a force, and due to only the rotation and the revolution of the planet takes place around the sun. So student, this is what all the things which I was supposed to tell you, all the basic concept. I hope my students has enjoyed my session. Today all their small basic concept is get cleared. Okay, so what are the things which we have seen today, students? We will revise once again. First, we have seen introduction of Sir Isaac Newton, right? After that, we have seen the story behind gravitation, how the gravitation was discovered by Sir Isaac Newton. After that, what we have seen, students? We have seen 3 Newton's law. Newton's first law, which is also termed as law of inertia, with the help of example. Then we have seen Newton's second law. Then we have seen Newton's third law, right? After that, we have seen, student, circular motion. What is circular motion? Then we have seen centripetal force. Then we have seen the direction of the velocity when the object is in a circular motion. This all basic concept which we have seen today. So I think this all points are clear to you. Tomorrow there will be my second session, and we will go to the next topic related to this chapter. So thank you very much, student, for watching my session. Thank you so much. Thank you, ma'am. Hello.